Hi, today is October 21st, and we are doing a review of systems. So we've done systems with one variable, and we've done systems with two variables. What? That made no sense. We've done systems with two variables and systems with three variables, sorry. And we are going to look at systems with two variables today, and then tomorrow we will look back on three variables. So today it says to solve each system by elimination on this top part. So I'm going to do elimination. That's where we want something to cancel out. If you've joined me on my Zooms, then you know this is not my favorite method. So we're going to look at number 1. We've got 6x minus y equals negative 8, and then x minus 3y equals 10. So we want to get one of our variables to look exactly like the one below it. So I see that I can get the bottom x to be just like the top one if I multiply by a negative 6, or I can get the top y to look just like the bottom y if I multiply by a negative 3. So since negative 3 is a smaller number, that is what I'm going to use. So I'm going to take that first equation and multiply the whole thing by negative 3. And then I've got that x minus 3y equals 10. So I'm going to rewrite it. That way I can do the elimination right after, where it's all in one condensed form. So I have negative 18x plus 3y equals positive 24. X minus 3y equals 10. And now I'm going to add these together. What I wanted was to eliminate one of my variables, and I did. Negative 18x plus an x is negative 17x. 24 plus 10 is 34. And then I'll divide out that negative 17, and I get that x is negative 2. So now that I know what x is, I can plug it into either of these equations. Let's plug it into the bottom one. So I have negative 2 minus 3y equals 10. Add 2. Negative 3y equals 12. Divide by negative 3. And y equals negative 4. So I have what x equals and I have what y equals. So my solution is negative 2, negative 4. And I used elimination to get there because I subtracted out my y values, so that way I just had only x's to work with. And then again went back in and found my y value. Our next method to use to solve systems is by graphing. So looking at number 5, we're going to plot both of these lines. We're going to graph both of these lines. So remember, we've got y equals mx plus b, where m is the slope, which is rise over run, and then b is our y-intercept. So on this first equation, y equals negative 3/4 x plus 4. I have my plus 4 as my y-intercept, and then negative 3 over 4. So I'm going to go down 3 over 4. So my line looks like this. And then my next line is y equals x minus 3. So negative 3 is my y-intercept. And then I have a slope of 1 since there's no number in front of x. So that means I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. There it is. And that is their point of intersection. Their point of intersection is called the solution. So the solution was right here. So the solution on number 5 is 4, 1. And then our last method here is to solve by substitution. This is my favorite method. So like I said, elimination is not my favorite, substitution is my favorite. So looking at number 9, we want to get one of our variables equal to everything else. So we want it to say x equals blah 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 or y equals blah blah blah. I see that on number 9, this equation right here is almost solved for x because we have a coefficient of 1. So we're going to solve the first equation for x. And you can solve either equation for either variable. I just like to look for whichever one's going to be with the simplest steps. So I'm going with that first equation. I'll subtract negative 6y, well, subtract 6y, and x equals negative 6y minus 2. And then I will plug that in the other equation. So negative 5, instead of x, I'm writing negative 6y minus 2 minus 5y, and that equals 10. And then we'll distribute that negative 5. So get positive 30y plus 10 minus 5y equals 10. We have 30 minus 5 for those y's, so we get 25y plus 10 equals 10 minus 10. 25y equals 0. Divide by 25. And we get that y equals 0. So I know what y is, and I need to plug that back into what x was. So this would be x equals negative 6 times 0 minus 2. So x would equal negative 2. So my point of intersection, my solution would be negative 2, 0. Alright, so let's look at one of these word problems. We're going to do number 13. It says the difference of two numbers is 2 and their sum is 14. We want to find those numbers. So we're going to say our numbers are x and y. The difference is 2. And it doesn't matter the order since we don't know what either of them are. So normally we would say we want to write it backwards. But since I don't know what x is, I don't know what y is, the order does not matter right now. And their sum is 14. Whoa. Sorry. X plus y equals 14. And I see that I can use elimination because I have a negative y and a positive y. So I have two x's and they equal 16. So I'll divide out that 2 and x equals 8. So x equals 8 and then I need to find what y equals. So I'm going to use the second equation. So I have 8 plus y equals 14. I'll subtract 8 and I get that y equals 6. So x equals 8 and y equals 6. And then I just want to check if my answer makes sense. The difference between 8 and 6, 2. The sum of 8 and 6, 14. So I know my answer is correct. So then the rest of these are for you guys to do and then to submit for your homework assignment.